this video, we're going to think about why we have seasons on Earth, like summer and fall and winter and spring. Now, one theory that some folks might have is maybe it's due to the distance between the Earth and the Sun. We know that the Earth orbits the Sun. The Sun is where the great majority of the heat and the energy on the surface of the Earth comes from. And maybe it's the case that there's certain times of year when we are further from the Sun, and there's other times of year when we are closer to the Sun. Well, this doesn't actually hold up to why we have seasons, because first of all, when the northern hemisphere, the top half of Earth, has winter, the bottom hemisphere has summer, and vice versa. So it can't just be to the distance of the whole planet. It also turns out that when Earth is furthest from the Sun is in July, which is in the middle of summer in the northern hemisphere, and when we are closest to the Sun is actually in January, which we know tends to be our colder season in the northern hemisphere. So distance to the Sun does not hold up as to why we have seasons. The real reason why we have seasons is because of Earth's axial tilt, I guess you could say that, or its rotational tilt. Now, this picture shows that tilt, but before we go into it, I'd like to remind folks that this is nowhere near drawn at scale. The actual Sun has a diameter over 100 times that of Earth. 1 million Earths can fit in the Sun, and the actual distance between the Earth and the Sun is over 100 times the diameter between the Sun and Earth. But going back to tilt, and you can see that here in this picture, Earth's north pole does not point straight up from the plane of Earth's orbit around the Sun. What do I mean by the plane of Earth's orbit around the Sun? This red circle that you see, or this ellipse that you see, if you imagine that being on a surface of a table or a plane, that would be our orbital plane. And we can see that the North Pole does not go straight up from that, and the South Pole does not go straight down, that actually we're looking at an angle of about 23.5 degrees. And that's the reason why we have the seasons. To understand why that is the case, let's imagine Earth when the northern hemisphere is most pointed towards the Sun, which happens in late June. So let me draw the equator to help us visualize this a little bit. And let's compare that to when the northern hemisphere is most pointed away from the Sun, which happens in late December. And so I will draw the equator again to help us visualize this. And let's pick a similar point in the northern hemisphere. So let's pick a point that's a little bit above the equator. So let's say that point. And a comparable point in this scenario is going to be right over here. It's about that same distance above the equator. Notice, in late June in the northern hemisphere, the Sun is almost directly above this white point that we're seeing here, while in this scenario, the Sun is at an angle. The surface of the Earth is more like this, so the Sun's rays are coming at an angle. And if you think about it, think about the scenario, the difference between when the Sun is directly bearing down on something versus when it is coming at an angle. Let's say this is a side view of two surfaces, and the surface on the right has twice the surface area. You can see the side view has twice the length, so the surface area, if you were to see it in 3D, would be twice the surface area of what we have on the left here. But if you have the same amount of Sun coming from the same direction, so here, let me just draw 3 sun rays here. This is just indicative. And let me draw 3 sun rays here. Notice you have the same amount of energy, but here you're hitting twice the surface area. So the amount of energy per unit surface area is going to be half as much in this scenario, where the Sun is coming at an angle, versus this scenario, where the sunlight is coming more directly on top of that point. And wherever you go in the northern hemisphere, the angle is less direct in the winter than it is in the summer. Now, there's also some effects on the amount of daylight you get. For example, in the summer, when the northern hemisphere is most tilted towards the Earth, in the North Pole, you're going to have constant daylight, and in the South Pole, you're going to have constant nighttime. And then the opposite happens when the northern hemisphere is pointed away. And then when we think about spring and autumn in either hemisphere, you can see that the angle of Earth's rotation does not change from that 23.5 degrees, but in spring and autumn, the northern hemisphere is not pointed to or away from the sun. It's kind of just pointed to the side. So in these 2 points, comparable points on the northern or southern hemisphere are seeing similar angles of the actual sunlight.